So let's see. Can you hear me? Cool. Thank you for showing up. I appreciate it. My name is Peter DROUGGE. I work at Microsoft as a technical evangelist. And this session is about ML.NET, our machine learning framework and toolkit for .NET developers. So, show of hands, how many in here are .NET developers? Oh, well, let's do that again. That was nice. I'm going to take a photo. OK, one more time. With feeling. How many in here are .NET developers? Hey, awesome. Thank you. So I think you're so far at the right session. Let's do a bit more. How many of you are working with machine learning right now? So you're the only one at the right session. No, I'm kidding. This is gonna be good for you too. So hopefully you will get to take away something from it as well. So let's begin. Let's get this show on the road. I am going to tell you about ML.NET and try to give you understanding of what it is, what it's capable of doing, what we at Microsoft are doing to enhance it and the roadmap going forward, and where it's been as well as I'm going to show you demos. As many demos in the end that I can muster, because I think you're about fed up with PowerPoints by now. And this will be another PowerPoint session for a while, but I'll get to code later. So, ML.NET, the basics. What we had, and still do have, is a lot of things running on .NET. We have games running on .NET. We have websites and IoT devices. We have mobile phone applications and games, some extremely popular ones. And .NET Core made this even better. What we did not have was machine learning. So this is what we're adding now. Actually, what we added as a build, and it's what, 7 months ago or something? A bit more? So machine learning for .NET, the main principles of it is that it has to be open source, just like .NET Core. It is cross-platform, just like .NET Core, because it runs in .NET Core. Quite simple. It's proven and extensible. I will show you what I mean by that later on. But most and foremost, it is really for developers. It is our tool that we built for you as a C# developer or F# developer, so you can learn to benefit from the machine learning task that we have available. Because it's fun and it's cool. And it's crazy too. Open source is key in a lot of things that we do now. So in GitHub, actually let me do like this. It took like 2 minutes and then I'm going off script, but that's okay. So there's a good place to start. You go .NET/ML. Here you can find a lot of things like explore samples and read up on the documentations. And of course, the link to the GitHub repo. So github.com/.NET/machine learning. This repo holds all the code, all the issues, all the planned projects that we're doing, as in every release cadence is planned right in the open. There is no dark hidden rooms in a cellar somewhere. It's just plain nice. So you can see in the issues, there's a bit of them. They're being worked on. There's a lot of pull requests. And in the projects, as I said, I mean, version 8 and version 9 is already planned, and there's projects created for them. We're at 0.7 now. So let's go back here. We love contributions, big and small. I mean, this is probably the smallest one I've made. It's changing a typo. Every single contribution is welcome, and we appreciate very much, because the collaborative world of open source is super awesome. It's fascinating, and we We want to build this tool for you, not from us to force you to do something, but to give you what you want. So if you have issues, if you have ideas, if you want to contribute, then go ahead and do so, because it is very welcome, and we can't do it without you. We've come a long way. At build, the release was 0.1 preview. It's kind of brave to do that one. 0.1 preview and call it a release. It had some really basic stuff for regression and classification, but you could just pretty much read in a CSV file and do some simple stuff with it. And we introduced the learning pipeline, which actually is for like a couple of weeks, but really was the way to do machine learning with ML.NET. I will show you this pipeline and what it does, and then I'll tell you to forget all about it because we're changing it. It's still point something preview, so I hope we get away with that. Point 2 added clustering and unsupervised learning. Also added cross-validation and support for training on a data set that wasn't just a CSV. So now you could do collection data source instead. Pretty much like take something from either your database or whatever and map it as a data source. Made it more useful. You can kind of see where this is going. Adds more and more stuff. Point 3, we added the ONNX export, which is very cool. We improved binary classification, multi-class classification, and regression by adding the light GBM and FFMs, the field-aware factorization machines. We added ensemble learners. So instead of just having one learner, you can have several learners in one solution, and you get the average of that instead as a scoring. Becomes more robust. We added the latent Dirichlet allocation, which is a transform for topic modeling, and then OVA multi-class learner as well. Point 4 was a lot of improvements for natural language. So word embedding transform, and also improved the speed of the learners by adding the stochastic gradient descent in parallel. And finally, we sort of caught up a bit with the F# thing. Any of you in here are F# developers by any chance? Oh, that's a lot of you. Okay, point 5. We added a new API. Well, we sort of took a first step towards a new API. Still, the learning pipeline is still there, so it sort of was in a very, very early stage. And we added the support for scoring using pre-trained models. That is, now you can actually take a TensorFlow pre-trained model and import it into ML.NET and use the scoring from that. It's very cool. Point 6, we changed the new API again. We're gonna land this, don't worry. The learning pipeline is going to be deprecated, but it's still available. It's just been moved to a legacy namespace. So when you actually read something and you see .legacy, you know that, no, maybe I'm not going to touch that one. It still works just fine. Now you can also score using pre-trained models from different ONNX models. And a bunch of performance improvements. Point 7 that we just released a couple of weeks ago added recommender support, a better recommender support, by using matrix factorization. There's actually 2 ways of doing recommenders. We added anomaly detection, both for a spike detection, which is where you look at just a stream and you identify spikes like anomalies, outliers, and then change point detection, which is sort of when you have a series of changes, like if a seasonality is changing or something. improved customizability pipelines is because now we added the option for you to create your own transformers, your own, well, yeah, transformers. It's not the transformers as in Optimus Prime, but it's something else. Now you can run in 32-bit as well, but if you do that, you cannot use TensorFlow. And also, we added a very experimental binding called Nimbus ML, which is tying Python and ML.NET together. It is a proven framework. It is, even though it's 0.7 preview, the code that actually is behind all this is something that we've had at Microsoft for over a decade. And it's built into Windows 10, it's built into Excel and PowerPoint. But that code base is not, let's just say it's not very developer friendly. It was a very internal tool. But that is what's behind this. And Microsoft Research created that tool a long time ago. Microsoft Research has been around for more than 20 years. So the brains there, they're like wicked smart. When I see some of these algorithms, I turn them upside down. I can't figure out where to start. And they say, oh, but this is the easy version of it. I go, yeah. So as a framework for developers, this was and still is the key. It is for developers. It is supposed to be a developer-friendly API. It's supposed to be easy to use. You have transformers, and you have learners. Learners being like the algorithm parts, if you will. And transformers being all kinds of ways that you work with data. So you make them categorical, you normalize numbers and stuff like that. The extensions part is also why it's a framework, why it's a sort of toolkit, because we're not just creating our version of machine learning, but we're connecting them to everyone else. So with the ONNX and TensorFlow, you can make the best of both worlds. So you can use your TensorFlow model straight into your code. Clicker stopped working. That's good. Okay, I'll go with just doing like this instead. There are a lot of things that you can do with ML.NET right now. So you can do sentiment analysis, which is figuring out if a text is positive or negative. You can do issue classification on your GitHub issues automatically. You can do image classifications as well as object detection. You can do forecasting to see if sales are going to go up or down. Predictive maintenance, always a hype thing if you do a lot of IT stuff. Recommendations for shopping carts or something. Recommendations are a very, very good way of introducing machine learning into an application. And customer segmentation, when you don't know the structure and how your customers sort of group together, you can still use machine learning to position them in groups and try to figure out why that happened. So let's start by looking at how you go ahead and actually make this happen. This fella here is Visual Studio. I'm sure you've seen it before. If I do a new project, we'll call it something super useful, like Console App 2. As I said, it's a developer tool. And since we're playing nice with developers, ML.NET is a NuGet package. There we go. In order to make this work, see if I can zoom in, you can see it. We just go install package Microsoft.ml. And it should go very much faster than this. So, and that was it, right? So now we have machine learning capabilities directly into our solution. It shouldn't be an installer. It shouldn't be taking long at all. It should be just like that. And everything's in, I can get like our context, so Microsoft. Seed it with something. And you just start building. So you build a pipeline and you figure out which transformers you're going to use on your data, and you get it in, and you create your model, and then you do all kinds of stuff with it. I'll show you more. Well, that is how you install it. And now it's back. I don't know what I did. Okay, so this is the learner pipeline that I was talking about, that you're going to forget about. This is the way it worked anyway, and the principles are very much the same. So you have a data structure, and then you load it, and you transform it, and then you get your learner, your model, that you then use for scoring and evaluating. To put this into context, I'm just going to PowerPoint code for you for a bit. It's great. We're trying to predict the survivals for Titanic. There's a data set that's available that shows you all the passengers for Titanic and whether or not they survive. Right now, they're like all gone, but I guess. So what we do is that we take this data, we massage it a bit to shape it into the right format, make sure there's no missing values or stuff like that. So we get a pipeline, and we load that CSV file into the pipeline, which means that we take this data and we apply it as a collection of this object. Okay? Don't pay too much attention because this sort of goes away, but once that's done, we added a few transformers. So one's the categorical one hot vectorizer, and the other one's the column concatenator. So the end one, the column concatenator, is because ML.NET works on just one single feature set column. So it doesn't work on the entire data set. It picks a fixed features column. And then we select a learner. So in this case, I've selected a fast-free binary classifier. It's a binary as in A or B or 1 or 0. Will they survive or die? There's also as the multi-class classifiers, which is when you're trying to predict something with 3 or more classes. But for yes or no, binary. And then we get our prediction model. So we train the pipeline, and we evaluate the model, get the metrics for it. Metrics are always good to see how it's performing. And that was it. Just a few lines of code in order to predict if people will survive the Titanic. Now we're just tearing the hell out of that and making something more fun. That pipeline had its limitations. It was a transform-only pipeline. You couldn't use transform-only pipelines. So in a lot of times, you really want to do that. You want to have a pipeline that massages data and gets it ready for you without actually putting a learner in there and running all that stuff too. You can put that in later on. And it was hard to look into the model and see what it did. So we need to fix that too. The new API is also using a more well-known terminology instead of our own, which makes it easier if you're collaborating between like Python and TensorFlow or scikit-learn. The idea for the original API then, for this one, was to use as well strong types in .NET and to create like a dynamic and static versions of the API. But these are the new concepts of the API that we're working on. has a 0.7. So you have the data. It's a interface of iData view. It's an immutable, lazy-valed, schematized dataset. The immutable part here is the key. And transformers are the ones that takes the data, works on it, and returns the transformed data. Simple as that. The reader creates an instance and returns it in that format. The estimators are the objects that learn from it. And the output of an estimator is, in fact, a transformer. And then we have a prediction function, which runs on just one single piece of the data and produces the prediction output. So it looks like this. And to explain that one a bit instead, let's look at it like this. We're trying to predict a sentiment of text, right? Is this comment really poisonous? Is it rude? Is it bad? Or is it just plain awesome? 1 or 0. Toxicity is 1, not toxic, 0. That's our data. Then we transform it. So we take that text, we do a text featurizer, and out comes a set of numbers. Why? Because machine learning will not work on text. It has to work on numbers. That's why. The estimator is responsible for taking that and creating the transformer, the model, if you will. Some refer to it as a model, some refer to it as a learner, but in reality, it's a transformer. So the input to the transforms are data, and out is data. The input for the estimator is data, but out comes a transformer. And then we use that to predict the next in line, so to say. So a Kanban is rude if you like da-da-da, and it gets a toxicity of 1 because it's rude. Okay? This is what it looks like now. Ish. It'll probably change as well. Nah, it will not change that much. So we have a text loader and an iData view, and the reader reads from a multiply in this case. Actually, this code is a bit old. I should update it. And then we do a text transform. We fit the model on the data. And then we test it as well, because one part is training and one part is testing. Now, when you work with the data here, make sure to split your data set up in 2. You have 1 to train and 1 to test. If you don't do that, your model is going to perform extremely well, because you've already trained it on everything that you're trying to test it on. So if you see a scoring of 100%, you sort of figure out that something's probably not right. And then we predict based on that. This is really not that much a difference. It's more fluent API. You can change things in here as well. So you can chain transformers. So let's just try and look at all of these in action for as much time as we have, because that was about it with PowerPoint, I think. Let's pick this one. Or not. I thought I had a studio here. Okay, let's just open it then. Where am I? There. So, I have a solution here with a lot of samples. Without sending you out the door, these samples will be in a link later on that you can get for yourself. So, I think I need my cheat sheet to see. Let's say that we want to do customer segmentation. So the problem from this point of view is that we don't know how customers relate to each other, and if we can put them into like customer groups and segment the data. But we have data available on what they bought and the offerings that we give them. So now we can use clustering to make sense of that. So out here, we have one project for training the model and one for predicting the model, predicting the outcome of it. Deal here is that you don't train the model every time you run your code. That is just not efficient at all. And by splitting them up, you can put a whole different lifecycle management on training and retraining, and just focusing on operationalizing the part where you're using the prediction. And we do that by allowing you to actually state the trained model locally on disk, so you can check it into source code, you can embed it into an assembly. It's pretty cool. So let's look at some code. This program out here, I don't think I need to zoom in anymore. We have some paths for our data sets and an output that we want to put the model into. So we pre-process the data. We create a machine learning context so we can share across the components. And then we load the data with splitting up features and last name. And then we do in the pipeline a PCA analysis, principal component analysis, and a one-hot encoding. So those are transformers, still in one pipeline. And then we added some helpers, so we actually, at this point in the pipeline, we can peek into the pipeline and see what we have. Then we go and create the training pipeline. Sorry. And I'm picking a k-means clustering algorithm here. It's an unsupervised algorithm. And we append that one. And then we're fitting the model to the data. That means that we get our trained learner, our model. So let's see this running. Hopefully. Okay. I will walk you through what this does. Can you see that fine, or should I zoom in more? Good. So these are our input files. It tells you a bit about whether there are and how many rows there are. Then we peek into the data view, as I said earlier. So we're showing 10 rows, and we can see the contents of that. This is when we do the same peek, but now it's just for the features column, and as we want, it's numbers. It's a lot of numbers. Then we're training the model, and we're evaluating it. So the metrics, and then we're getting the retail clustering as a zip. That means that we've gone ahead and built our model and stored it to disk. So now, if I go out here, that's not what I was going to do. And we look at this guy. Let's just set that one to run. So the predictor loads the model from the zip file. This is just a helper function, but it really just reads the zip and loads it up as a model. And then it creates the clusters for this clustering algorithm. So if you run that one, zoom that one in a bit. This is the output of that code that we just ran. So now we can actually visualize and see that there are 3 different groups that our data was segmented into. And we can then get that knowledge back into our data set and make sense of how we look at the customers in this case. Okay? Let's see if we can do another demo. How about fraud detection? Fraud detection is cool. Doing fraud is bad. Okay, so we stop that one. Out here, let's see, credit card fraud detection. Okay. This one's also split up in a trainer and a predictor. And it looks pretty much the same in a sense that the pipeline is the way the pipeline runs. You load the data, you do something to it, like transforming it and stuff like that. Then you get your estimator, and then you use it. Or you store it, and then you load it back up, and then you use it. Okay? So let's see. We have our dataset files for credit card frauds. We set a context with a seed. This is a helper for model builder. We're using a fast tree. You can just look into that. It's easy. So we're concatenating a lot of features. All of the features, all of the columns in the dataset, we're concatenating into one features. And then we're normalizing, getting better numerical values. Instead of having them all over the place as range, you just sort of shrink it down. It's much easier for a machine to work on it. And then we have a fast tree binary classification. So let's see. We can run this one. Let's scroll back up. So now we're just peeking into the data. And here we're showing skipped ahead. 4 transactions, fraudulent, and 4 non-fraudulent. And here we have 4 fraudulent and non-fraudulent from the train data and test data. We're just using the train data part now. And down here, we're testing it. So the accuracy, let's do this. The accuracy under here, 0.99% accurate. It's fairly good for this data. And the area under curve, or the ROC in this case, is 97.5. It's a very performant one. Let's see if it does what it's supposed to be doing. It has saved the model. Once again, we're doing that. So we're stating it, because then we can read it back up. Didn't need to zoom that one. So if we change to the predictor, we can see same kind of code once again running. It gets the data, creates a predictor, and then we send in stuff that it hasn't seen before. So we inspected 5 transactions, and some of them are fraudulent, some not. Load up the tested model and start to do, sorry, a bit further down. Yeah, so these ones should be fraudulent, as in label is true, predicted label. Skipping too much here. Predicted label is true as well. And as you can see, it actually true, 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 true. Well, you get the picture. It does a very good job at identifying these now. It's just running locally. It's not in a super secret black box of magic that costs millions of dollars. You can probably still build those anyway, don't worry. And then the same for the false, the ones that aren't fraudulent. It's a full hit rate. So it does a good job. And that is how you can create something like that. Let's look at that sentiment analysis thing as well. Trying to make sense out of positive and negative text. We'll close this down and go into sentiment analysis. Uh-oh, I've changed something here. That's nice. Okay. We have our trained data and our test data. And these are, actually I should have shown you that, the locations of all these things. They're really, you can reuse your data sets. You don't have to store them in your project anywhere. So it's just a file on your computer. And in this case, they're super easy. We have a build, train, and evaluate, and save. Now, you've seen this now a couple of times. It's pretty much the same thing. You load the text, the data, you massage it with a couple of transformers. So in this case, we have one here. And then you peek into it if you want to, so you can see what it looks like. We're adding a trainer. So for the sentiment analysis, as I said, that's a binary classifier. We're just trying to figure out if it's positive or negative. Then we're training the model, and once again, we're storing it. No, would you look at that? We're not storing it. Actually, we're storing it, but we're not using another project for it. Getting way too many of these projects now. Okay, so let's look at this one. This makes a lot of sense. Keeping scrolling until it's done. So we have these texts out here. It's like, this is rude. Dude, you're rude, upload the curl, blah, blah, blah. And one is okay. Oh, okay, not okay. We peek into it when we've featurized it, and it's just a lot of numbers. Numbers are good for machines. We evaluate our model, and we can see that the area under curve is 95%. The accuracy, however, is 72%. It's not bad. Accuracy and the level of accuracy, it's all up to you. It's like, it's gonna be pretty freaking hard to get 99.999 or something. Sometimes 72 just works. It all depends on what you want to do with that. Although if you're doing like, I guess, medical stuff, I don't think something around 70% would be, just tell me where you did that in that case. But it's still, we saved it, we load it back up, and we do a prediction. So the text, this is a very rude movie. Prediction is a toxic sentiment with the scoring of 99.98%. It's useful for like comments on websites and stuff. Making sure, like, maybe if things go haywire and you have nothing but negative stuff or negative comments about product, you can be ahead of all the negative stuff by acting swiftly on it. Okay, what else we got? We got multi-class classification. So if you work with machine learning, you will see the iris dataset. It's a quite famous dataset, very well shaped, and it's super annoying. Pretty much just tries to categorize flowers into one of three categories based on petal length and width and sepal length and width. So just 4 features, really. And you guys said we have a train path and a test path because you do not use the same file. People don't do it. We can load. So load in. Concatenating all these features into one. And then using a multi-class classification and SDA, sorry. We're training it, and then we're putting it back out. So let's see the output of it. Oh, hello. I'm not doing that. I get so much blocked for doing that. Okay, here we go. Man, I shouldn't do stuff like that. Okay, we get a lot of metrics, but we can see for the log loss, closer to 0 is better. For class 3, it's really low. For class 2, it gets a bit worse. And for 3, just a wee bit worse. But what's interesting, though, is down here, when we try and test our model, see that the actual one for the first one is supposed to be setosa, and the predicted probability for setosa is 99%. And then we have Virginica. Actually did a good job with Virginica too, but versicolor, that's the hard one. It's like 54%. So 2 out of 3 were really good, and the third one, I would say maybe go and read up a bit on it and look into it. But for the threshold of 90-something, that's probably useful. A threshold below 60, flag that one and look into it. But that is a multi-class classification. Are you bored? Everyone's like, yeah. Okay, fine. I'll bore you some more, don't worry. Let's see. Let's do regression, trying to predict the price. So everyone can go home and have a stock price predictor and get like shitloads of money. If you can do it on a taxi fare. This is actually useful for me because I'm going to get a taxi back to the airport later. Should have used that example. I'm not even going to tell you what it's starting with right now. It's data. It's splitting, test, and train. Okay, so it's one of these. We read in the stuff. We do a lot of pre-processing on it. So you do one-hot encoding, and we normalize the numbers, and then we concatenate them into the features column. Remember? And we do peeking to just see what the shape of it is and how it looks like. We pick our trainer, and we're ready to go. So are we doing a good job at trying to predict cab fares and the prices for it? Let's see, we have a lot of data. We have the trip distance and pricing and all that stuff, and now it runs a lot. But this did a very good job. Let me just go and show you. So you can see here the predictions and the actual ones. They're very on track. So this cab is doing a good job. I wish the cabs in Sweden was like that. You go like, how much is it to go to somewhere? And go, yeah, I don't know, it depends. It's like machine learning. That's the best answer in machine learning. It depends. But the ones that are like data science, they often go like this, go like, yeah, it depends. Z is like really super smart people. But if we look at the chart, all the predictions are very on track. So the accuracy for this one is pretty fantastic. So if you replace that data set with a data set from here, then you can try and have fun with the cab drivers. Or argue less, maybe. That's what I'd do. What else haven't we touched? Recommenders. Yeah, I said recommenders are good. Recommenders are awesome. They're a great way of trying to find a way for inserting machine learning into applications or solutions, especially if you have customer-facing stuff. Let's see, we're supposed to have one here. Movie recommendation. Yeah, that's the one. So the movie recommendation has a train and test file. Go figure. It also has another movies that we're going to use later for predictions. So we're loading the data view with training stuff. We're mapping values to keys. Then we're using the chain process, so we can append another transformer, and we can append another one as well. Everything's nice. This is the matrix factorization trainer. So that is the output that we'll get our model from. And then we're fitting it so we can get it out here. Yeah, we could just do like this, actually. I haven't shown you this. That's bad of me. So if we run, this is Visual Studio, right? So we can look at all these things. Wow, you can't see anything, but I can. Let's see. So we have our transformers. You can go in and you can debug machine learning, just like you do any sort of .NET code. I'm sorry for not starting with that. I guess that should be kind of good to know. What else can I show you? I can show you the train data view, the schema for it, columns. You can introspect and inspect a lot of things. But let's keep running that. We get a prediction for a movie rating, 1 to 5 stars. For this user, if GoldenEye was the movie, we're predicting it to be 3.7. Now this is based off some of what that user has seen and rated, and then what others have rated and seen, and then you sort of combine the two. I think I'm done with cooking code. Unfortunately, I'm going back here. I'm running out of time. Okay, so what did we look at? We did look at all of those, I think. We saw clustering, we saw binary classification and multi-class classification, saw regression and a recommender. For loading a model, it is as simple as reading it from a stream, from a file stream. If you embed it as an assembly, then you can just read it in from that assembly and use it straight away. There is a UI for this on its way. It is not here yet, but it's been worked on, because creating transformers and working with data, even automating some of this stuff is very, very useful in a UI perspective. What's next? A lot of API improvements that I've been sort of warning you about, but let's look at them as improvements. They're positive, they're nice. Change is good. Breaking change is bad. Okay, we're doing more ML tasks and scenarios, of course, so there'll be all that coming in 0.8, 0.9, and the Lucius 1.0, whenever that'll be. The release cadence has been roughly like every 3 to 4 weeks, if you look historically. If that goes, let's do prediction. If that runs, you can do linear prediction, as you can do it in machine learning.NET, for example, and see where that will be. I'll leave it to you. We're adding more features for deep learning, scale out on Azure, so you can use Azure Compute instead of just your normal local compute. The graphical user interface that I showed you briefly, and of course tooling. Tooling is key. These are some of the resources that you want to look into if you start using this. Especially the samples repo right there. Those are all the samples that I showed you. And some more. It's a great way of getting started. And do use these new samples. Don't go with the old ones, unless you want that headache. Yeah, with that, it stopped working. Okay, it is still early, somewhat, but we've passed the halfway point and we're getting there. It is for developers. It's built only for you in mind first. So be with us on this journey. That would be awesome. And it's open source, right? So when I say come join us and be with us, please join us and be with us. If this is to your liking, then go crazy. I always end with stuff like this. Machine learning is great, but causation does not. Correlation and causation. Okay. You can't really. I know, these are funny. I don't know which one I picked. Yeah. So I don't think eating a lot of cheese makes you die tangled up in your bed sheets. And I don't think being tangled up or dead in your bed sheets makes a lot of people eat a lot of cheese. But a machine would think that these two are very correlated and there's something you should look into. So this is why we're still needed for a while anyway. With that, thanks for listening. You've been awesome. If there's any questions, just fire away afterwards or find me out there somewhere. Thank you.